Not yet.
Live. Okay, so topic, inverse functions. Okay, and it is 9:17:19. Okay, so before we start, to do an inverse, we know all we're going to do, the biggest thing is we're going to switch. You're basically going to switch x's and y's. That's how you do it, okay? So, example 1, if fx equals x squared minus 4, find its inverse. Okay, so to get the inverse, oh, I'm on the back. My bad. My bad.
Oh,
Dang,
whoopsie
rabbits.
daisies.
I did it again.
Back to me, 3, 4.
Okay, so first of all, example 1, determine if it's 1 to 1. So x cubed looks like this. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. And the graph looks like this. Okay, there it is.
Oh,
That's what the graph looks like.
Wait, 2 to what?
So 1 cubed, 2 cubed, 1 cubed is 1, 2 cubed is 8, negative 1 cubed is negative 1, Landon, negative 2 cubed is negative 8, okay? Now, it's a function. Does it have an inverse? Does it pass a horizontal line test? Yes.
Yes.
Yes, I mean if you're to draw a horizontal line anywhere, and every x has exactly one y, and every y has exactly one x. So yes, this one has an inverse. Now its inverse, we'll talk about the inverse equation later, but it does have an inverse, okay? Now b, okay, if I graph this, 1, 2, 3, 4, 1, 1, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here is my parabola, all right? It is a function. Does it have an inverse? Does it have an inverse?
no.
No, because it fails the horizontal line test.
Why? How?
Okay, if I draw a horizontal line through, and if it touches the graph in more than one point, it is not. Okay, so no. Okay, and I'm going to come back and talk about these a little bit more in just a second, okay? C. It's a square root graph. Square root graph looks like this. 1, 2, 3, 4, 2. Okay, here's my square root graph. Okay,
Gracias.
that's my square root graph. Okay, now, does it have an inverse? Yes, because you can draw a horizontal line and it will only hit one point, so every y has exactly one x. The answer is yes. Now, let's take a look briefly at their equations, okay? So, I'm going to shift this up, and we're talking about their equations. So, a, y equals x cubed. Now, got to listen. To find the inverse, do an inverse, you switch x and y's. The inverse is just y becomes x becomes y. So I'm going to rewrite this as x equals y cubed. Okay, so I'm finding the inverse equation, right? Okay, now,
Wait for what one?
so for a, this a right here, okay, if I'm going to find its inverse equation, right, I switch, x becomes y. That's all you do for an inverse. X becomes y, y becomes x. And I did that. Y equals x cubed, but I rewrote it as x equals y cubed. I switched the x to y's. Can you solve for y? What would you do to solve for y? Cube root it. Cube root it. So my inverse would be y is equal to the cube root of x. Okay? That's the inverse. Okay? Now the inverse equation, if we were to graph it, its inverse equation would look like this. I'm going to graph this down below on its graph. If I were to graph the inverse equation, it would look like this. Okay, and that is my f inverse of x equals cube root of x. And we've graphed those before. Now what we notice is that they are reflections of each other over the line y equals x. Because if x becomes y and y becomes x, it's a reflection over the line. Can you see the reflection? Can you guys see that? If you're to fold one graph over to the other, okay? Now let's look at b. What about its inverse equation? So I have on b, you watching? I have a y equals x squared minus 4. Okay, this is an important one to watch. It's going to prove why it doesn't have an inverse, okay? So if you want the inverse, x's become y's, y's become x's. So I switch them over. X equals y squared minus 4, right? So far I just switched, that's all I did. So now solve, let's solve for y. What do? Plus 4. And then what do? How many answers? How many answers? It's really important. How many answers? Two. Two. It has to be 2. So with 2 answers, you get 2 equations, right? How can it have an inverse if it has 2 answers? It can't. So if you take a look at this, you get plus or minus the square root of x plus 4.
Oh yeah, and then you get minus. Oh yeah.
So if you were to graph that, you are going to have, now let me go ahead and put it on the board for you so you can see it. You're going to graph this. It's going to look like this. Okay, watch the graph. So the graph looks like this, but it also looks like this. Here's the plus part. Here's the positive square root of, actually it's back here. I'm bad. Actually goes right there. I missed it. Got it in the wrong spot. It's okay. It really is here. I got ahead of myself. Goes to there and there, right? Now, so here's your positive square root of x plus minus 4, and here's your negative, right? And this is not a function. Not only that, but it's 2 different equations. So this does not have an inverse. Does that look? You can see why. Do you see why it doesn't have an inverse?
Yes.
First of all, it doesn't pass it's not a function. Second of all, it took 2 equations to make it, right? So it does not have an inverse. Okay, now the third one, C, you've got y equals the square root of x, okay? And so switch the variables, make it be x equals the square root of y. How are you going to solve? How are you going to solve? Square it, right? Square it. Y equals x squared. Now, check this out. This is really important.
You mean x squared equals y?
Y equals x squared.
What?
Same thing. Same thing.
Okay.
Now, you got to watch this. It's a parabola, correct?
Yeah.
But I didn't draw the back half of the parabola.
It doesn't.
Because I don't have the other half. I have the x values, the positive x values, but there's no negative x values, so I wouldn't draw the other part of the parabola, okay? So, if it has an inverse, we can draw it. If it doesn't have an inverse, we're done, unless we fix it, okay? So, example 2. Let's change the domain. So if I go back to example 2, it was null. So if I go back to example 2 and say this, on my domain change, let's make sure we let x be greater than or equal to 0. If I do that, then what I've done is taken my parabola, and I'm only going to graph this part of the parabola. Okay? There's my domain change. Okay? Now, why did I do that? It's gonna pass the horizontal line test now, right? This will have an inverse, right? This will have an inverse. So if I make my domain change and say only take the positive half, I won't have the other part of the parabola, right? So then, okay, did I make it 1-to-1? Yeah. First of all, it would now pass my horizontal line test. Every x has one y and every y has one x because I got rid of the back part of the half. Okay? Now, example 3. Let's graph it. Okay, I've got y equals 3x plus 4, right? 1, 2, 3, 4. And I'm going to go up 3. Yeah. I'm going to go up 1, 2, 3 over 1. Down 3 over 1. 1, 2, 3, 1. Okay.
Wait, did you say down 3? 3 over 1.
Down 3, back 1.
But wouldn't that be...
He's just scratching the equation that's right there.
Right, so all I'm doing is this. So,
You started
Zoe,
at
no, it's okay. So if I start at 4,
Well,
you'll see
no,
it.
I thought that we started at 3 and then I was really confused.
No,
and
we
then-
started at 4,
but I got
right?
it now.
Up 3 over 1. The problem is I'm going to go off my graph, so I did just back. I do it backwards, right?
Okay, thank you.
Just went backwards. Okay, now I'm going to do this like first, like I showed you in Algebra 2. Okay, the way I did it in Algebra 2 was we had points. Okay, I have a point at 1, 2, 3, 4, 5, 6, 7. I had a point at 0, 4. I've got a point at -1, 1. I've got a point at -2, -2, and I have a point at 1, 2, 3, -3, 1, 2, 3, 4, 5. Okay? Okay, you see it?
Yeah.
Now, its inverse is switch the x and y's. Okay, so its inverse are going to have these points. There you go. You've done this before, haven't you? Yep. So my inverse is going to be at 7, 1. 1, 2, 3, 4, 5, 6, 7, 1. My inverse is going to be at 4, 0. 1, 2, 3, 4, 0. My inverse is going to be at -1, 1. So, 1, -1, sorry. My inverse is the same spot, right? My inverse is going to be at -5, -2. Okay?
Wait, how did you do the...
-5, -3, sorry. Hold on, Zoe. So, I took, and I'll go slowly through this, I took all of the points on my graph, and I switched them.
So the -2, 2 is still -2, 2.
Right, yeah, and I switched, okay? And then if I draw my line, so I draw my line, it's right here, okay? Now that's my inverse, so we'll call it F inverse of x, okay?
Over 3 down 1.
You're ahead of me. Hold on to that thought. You're ahead of me, okay? You are ahead of me. Now, what we know is this. It is a reflection over the line y equals x, okay? Can you see that? So they are a reflection of each other over the line y equals x. And if you can kind of visualize that, you can kind of see that if you were to fold it over this yellow line, it folds over, right? Can you see that? So the easiest way is point by point point. Now, the -2, -2 makes sense that it would be on the line, right?
Wait,
Because
can you
if
literally just fold it like
Yeah.
your test
Yeah.
paper?
Mhm. Yeah,
And then copy.
yeah, that'll work. Be careful though, right? Just you have to be super careful. Now, how about its equation? Now, Sydney, you are very close. So the equation, to find the equation,
Isn't it -2? It's y equals 3 over 1 x plus minus -2.
close, super close. Let's see how close you are, okay? So, the original is y equals 3x plus 4, right? Switch.
X equals
Oh, it's 1 over
3y.
3.
X equals 3y plus 4. Good. Switch, right? Solve for y.
Wait,
Solve for y.
did you scoot it over?
Yeah. So switch, we made it x equals 3y plus 4, right? We switched x and y. So what we're doing is switching all of the x's, all of the y's, because x and y represent all of them, right? So let's solve. Bring over the 4, right? Add 4, minus 4, minus 4. Divide by 3.
X minus 4 over 3.
So it's a 1/3 x minus 4/3 equals y. Or, I like this better, F inverse, because that's the symbol, equals a 1/3 x minus 4/3. Okay, now,
Why is it 1/3 x minus 4/3?
great question. So right here, Landon, that's a 1x, right? We don't normally write it, but we have to divide both. So here's my 1/3 1/3 and my negative 4 terms, because you divide both terms by 1/3 and my negative 4/3, okay? Now, here's another thing. If we are switching x and y's, think this through. Check it out. I'm going to bring the graph down. Okay? Okay, we're switching x. Let me bring the graph down. Okay, so, first of all, slope. This, Sydney, you had it. Slope. Rise over run. Or the y's over the x's, right? Switch it. Right, so our slope was 3/1, rise over run, y's over x's. So now our new slope was 1/3. That makes sense. Now check this out, okay? I have a y-intercept of 0, 4. Now becomes an x-intercept. My y-intercept becomes an x-intercept because x and y switch. My x-intercept becomes a y-intercept in the exact same spot, right? Because x's and y's have been switched, okay? All right, now turn the page. Okay, now, example 4. So we actually did example 4. Let's move to example 5, right?
Okay.
What do you want me to do 4? We can do 4. I'm looking at time. But okay, let's do 4 real quickly.
I'm trying to do both.
We'll do this one. This one actually we can do pretty quickly, okay? 1, 2, 3, 4, 5. So I want to use a pencil on this one because I'm going to erase. Okay, here's my parabola, correct? And it does not have an inverse, right?
Yeah.
So we're going to fix it.
Wait, can I ask you a question?
Yes.
Never mind.
So let's fix. So if we can get rid of 1/2 of the graph, okay? If I need to get rid of the back half of the graph or the front half, it would work, right? Because right now it's not going to pass a horizontal test, right? So the way we get rid of it is change its domain. So let's get rid of the back half. Let's just go straight up here and say x is greater than or equal to 0. And then we can erase this back half, okay? So we fix it. So it's fixed domain by saying x has to be greater than or equal to 0. When we do that, the back half of the graph disappears, right? And all we have is this part of the parabola. And this part of the parabola has an inverse, okay? Now, what's the domain or range? Well, the domain or range of this domain is x is greater than or equal to 0. And the range is y is greater than or equal to -4. Okay, I'll put that down and think about it, okay? The domain of my fixed graph, x is greater than or equal to 0, and y is greater than or equal to -4, correct?
Oh, yeah.
Yes.
The inverse. The inverse looks like this. This is the point 0, -4, which becomes -4, 0. This is the point 1, -3 becomes -3, 1. This is the point 2, 0 becomes 0, 2. This point at 3, 9 becomes, 3, 5 becomes 5, 3. Here is my inverse equation. So I just switched the points. 0, -4 becomes -4, 0. 1, -3 becomes -3, 1. 2, 0 becomes 0, 2, right? 3, 5 becomes 5, 3. So there's the inverse, okay? That's my inverse right there, okay? That's my F inverse. I'll wait for you because I want to talk about the domain and range of the inverse. How am I doing?
Just splendid. Just fantastic.
So now, domain of the inverse. What's the domain of the inverse? What's the domain of the inverse? What is the domain of the inverse? X is greater than or equal to -4. What's the range?
Y is greater than or equal to 0.
Now, one more time. We switched x and y, Zoe. We switched x and y. So the domain of the original has to become the range of the inverse. Look at it. We switch x's and y's, right? So the range of the original has to become the domain of the inverse. Has to be because we switched x and y's, right? Domain is all the x's. Range is all the y's. When we switch it around, the domain and the range have to switch also, okay? All right. All right, now, example 5, I think I won't do, because that's in our homework. We'll do it together, okay? So, let me give you your sheet, okay? And I'll stop there.